What I am going to do in this video is to talk little bit about UV visible spectroscopy and the different electronic excitations present in it. The range of UV visible spectroscopy is from 200 to 800 nanometer. Specifically for UV, this range is 200 to 400 nanometer, and for visible it is 400 to 800 nanometer. When such type of UV visible radiations get exposed with the molecule, at that time the electrons which are present in bonding molecular orbital as well as non-bonding molecular orbital, they will get promoted to the anti-bonding molecular orbital, such as the sigma star as well as the pi star. Here this sigma as well as the pi are bonding molecular orbitals. These are bonding molecular orbitals, and N stands for the non-bonding electrons, and this sigma star as well as pi star represent the anti-bonding molecular orbitals. Now when molecule get exposed with UV visible radiations, at that time bonding as well as non-bonding electrons will get transfer from ground state to excited state, that is anti-bonding molecular orbitals. In UV visible spectroscopy, we have different types of electronic transitions such as sigma to sigma star. So here we have sigma to sigma star transition. In case of sigma to sigma star transition, the energy required is higher because the sigma bond is strong bond and it is tightly held with the other atoms. That's why it requires the higher energy. To study such type of high energy transitions, that is below 200 nanometers, so these transitions will absorb below 200 nanometers. So when we have to study such type of transitions, at that time the entire path length must be evacuated, and therefore the region below 200 nanometer is commonly called vacuum ultraviolet region. So let me write that this is generally known as vacuum UV region, vacuum ultraviolet region. The second electronic transition is non-bonding to sigma star. Non-bonding to sigma star. Such type of electronic excitation involves the saturated molecules which contain heteroatoms such as oxygen, nitrogen. So if you have the specific example like alcohol, amines, all these molecules will come under non-bonding to sigma star transition. We have then pi to pi star transition, pi to pi star transition, and the molecule which contain the carbon-carbon double bonds or the carbon-carbon triple bond. So such type of molecules, so alkenes as well as all the alkynes will show pi to pi star transition. The last electronic transition is non-bonding to sigma star transition. Non-bonding to sigma star transition. In non-bonding to sigma star transition, the energy required is very less as compared to the previous three one, and generally the molecules involved are like carbon oxygen double bond with non-bonding electrons on oxygen, carbon-nitrogen double bond with non-bonding electrons on nitrogen. So such type of compound shows the electronic excitation like non-bonding to pi star.